This is Unit 8, Solutions and Solubility. Lesson 4, Concentrations of Solutions. How can the concentration of a solution be expressed quantitatively? By the objectives of this lesson, I can calculate the percent by mass and percent by volume of a solution. I can calculate the parts per million of a solution, and I can calculate the molarity of a solution. So do now. So concentration is defined as the amount of solute dissolved in solution. If I have something that is dilute, that means I have a little bit of solute in the solution. If I have something that's concentrated, that means I have lots of solute in the solution. The percent by mass and the percent by volume can both be found on your reference table in Table T. So you're going to use the percent composition formula. So the percent by mass is equal to the mass of the part, which is going to be the solute, over the mass of the whole, which is the solution, times 100. When you do the mass of the whole, you have to make sure you add the grams of your solution and as well as the grams of your solute. When you do the percent by volume, you'll use the same formula, except it's going to be the volume of the solute over the volume of the solution, which is the whole thing, times 100. So for example, what is the percent by mass of glucose if 2.8 grams of glucose is dissolved in a 100-gram solution? So this is a little different. So you're going to use your percent by mass. So the percent of your solute is the 2.8 grams, and the mass of your solution is the 100 grams. In reality, what you really need to do is add the 100 plus the 2.8 to have your whole thing. But because it's such a small enough difference, sometimes we can get away with not doing that. So in this case, we just took the 2.8 divided by the 100 times 100. So it's 2.8% glucose. The percent by volume is very similar, except we're going to take the the volume of the solute. In this case, what is the percent by volume of 40 mils of acetone that is diluted with water to form a total volume of 300? So in this case, they told us our total volume is 300. Therefore, that's our total, our solution. We're going to take the volume of the part, so 40 divided by 300 times 100. That will get us 13.3% acetone. So stop and think. Okay, parts per million are also located on Table T. The parts per million is going to be the mass of the solute divided by the mass of the solution times 1 million. So parts per million times 1 million. So for example, a sample of water is found to contain 0.010 grams lead and 15 grams of solution. What is the concentration in parts per million? So in this case, our mass of our lead is small enough that we'll just take the mass of the solution. So the parts per million, 0.01 grams divided by 15 grams times 1 million will get us 670 ppm. So ppm is our unit for parts per million. So make sure you have your units when you're doing the concentration of ppm, parts per million. So stop and think. Molarity is our third unit of concentration. It's also located in Table T. Molarity is defined as the moles of the solute divided by the liters of solution. So our units are going to be moles per liter, or molarity, capital M. So as an example, a solution has a volume of 2.5 liters and contains 0.7 moles of sodium chloride. What is the molarity? So I'm going to take the moles of my solute divided by the liters of the solution. So 0.7 divided by 2.5, and that will equal 0.28 molarity. Molarity can also be translated directly into moles per liter. So that's something that you'll need to recognize for later. So stop and think. Okay, do a practice problem. This one I won't count. And then do this practice. I'll go over this in class. And stop and think again. This one's a little bit tricky, so give it a shot. And check your understanding. Okay, now you can calculate the percent by mass and the percent by volume of a solution. You can calculate the parts per million of a solution, and you can calculate the molarity of a solution.